Hi, everyone. Thank you for joining today. Before we jump into our content, we have a few polls that we're going to put up on the screen. So this poll is, do you use JSONB in your applications yet? So feel free to answer, and then we'll close the polling and look to see what everyone's experience has been so far.
Wow, this is good. I've not seen this before. This is very useful.
Okay, it looks like a good majority of you have answered our first question, so I'm going to end our polling here. I'll share the results with all of you so you have an idea of what your peers are saying. Great. Okay, that was poll number 1. So here we're going to launch poll number 2 for you. Much faster responses this time. Awesome. This is most of the people. So we're going to end the poll. Here are the results to our second question. Okay, and just one more poll question for all of you before we start. Okay, we'll wrap this one up. And here are the results. Okay. Well, thank you all for your early participation in our webinar. Hi, everyone. My name is Courtney Brown. I'm a Senior Marketing Manager here at EDB. I'm going to be your host today for our webinar, Power JSON with Postgres. I'm joined by Simon Riggs, Postgres Fellow here at EDB. Before we kick it off, though, I want to go over a few housekeeping items. This presentation is being recorded. We'll be sharing the recording along with the slides with all of you after the broadcast. All of your lines are currently muted. If you have any questions, please feel free to submit them in the question panel. Today's session is going to be about an hour. We expect the presentation to last most of the time, but any extra time we're going to allot to answer the Q&A that comes in. If we don't have time to address all of your questions, don't fear, we'll follow up afterwards with any attendee whose question was not answered. So with that, I will turn it over to Simon.
Thank you very much, Courtney. Can I just confirm that you can hear me okay, Courtney?
Yes, thanks.
Perfect, thank you. Okay, so what I'm going to talk about today is Power JSON. I'm going to take you through the basics. We're going to end with some intermediate stuff, but some of you will be very happy to know that we're not going to go to the advanced stuff today. What I've actually done is I've structured this webinar into 2 halves. And so the webinar today is part 1. We're going to talk about SQL development with JSON and particularly talk about indexing, which is probably everybody's favorite topic anyway. But then part 2 is going to go into much more advanced topics. Okay. Now the approach I'm taking with this webinar is that this is a detailed deep dive into code and how it works. What I mean by that is application level code. Okay, I'm not diving into the C level code that's inside the database itself, but I am going to be talking about things from a usage perspective. Okay, but so there's a lot of code on the screen, and I'm going to explain things in detail, which is what most people want in these circumstances. But if it wasn't what you wanted, then please forgive me. but part 2 is going to be very advanced, and that's happening in about a month's time. Okay, so just to let you know the shape of what we're doing today and next month. So my starting point, as ever, is to talk about PostgreSQL as the world's most advanced database. Obviously, you may already have heard that Postgres won the 2020 award for best database again. So that's very good. Now, Postgres has always worked with SQL and specifically adhering closely to the SQL standard. And there are many changes in that in Postgres 14. But what about JSON? I mean, JSON's like from another database, isn't it? I mean, you know, why would we do both SQL and JSON? Well, the truth of it is that JSON is now part of the SQL standard. And a lot of what we're going to see here is actually now standard SQL. And the reason it's part of that standard is to a certain extent because of the support that was added for JSON to PostgreSQL. Okay, so it's full on a normal, completely acceptable topic to talk about PostgreSQL and JSON in the same sentence and in the same webinar. Okay, and that you know, came about relatively lately in the history of Postgres, but not that you know, not recently. So actually, the JSON data type was added to PostgreSQL in 2012. So it's been available for nearly 9 years in Postgres, which is very good. So one of the stories I like to tell about that was that a load of people were saying, wouldn't it be lovely if Postgres did JSON? And so Robert Haas just went down, sat down for a couple of days, and in 1 week managed to turn out the first data type for JSON. Now, that illustrates a number of different things. First off, it just shows that JSON is just normal data, and we can manipulate it to inside Postgres in just the same way as we can manipulate any type of data. Okay, so it doesn't matter whether it's text or it's integer or GIS, we can manipulate it in Postgres. And that's actually what JSON is inside Postgres. It's not a weird add-on that you need to do. It's what we call a first order data type. So it's got the same treatment that you would get from integers or whatever. So it's indexable, searchable, compressible, completely usable alongside all of the other types of data. Now, just a few credits to the developers involved. Andrew Dunstan has been extensively involved across many different releases, committing code from a number of different people. So there's been quite a wide contribution in this area, but there has been significant work from a number of different people. Oleg Bartunov and his colleagues at Postgres Pro have done a lot of work on both indexing and also on the development of SQL JSON, so sort of SQL standards compliance. So thank you very much to those guys for their contributions. Now, Postgres did already support XML documents as well as full text search, arrays, nested record types. So there were actually lots of different sort of ways that you could use Postgres. And these are actually very similar to what we get with JSON. But I'm not going to talk about that at all. I'm just going to talk about the JSON stuff. But the point I'm trying to make here is that JSON is you know, a first-class citizen within the Postgres database and will remain so. Okay. And that means that we get all the benefits of replication, backup, the robustness of the server that you get with Postgres when you use JSON. So there's no caveats and say, oh my goodness, it's a bit unstable or something. No, it's perfectly fine. You can use it. And I'm going to show you how. So let's have a look at what JSON looks like. Well, what I did is I had a look on my laptop and I found that I had over 300 JSON files on my laptop already, and that's without really me putting any of it there. Okay, so these are files that I did not put on my laptop. So it's not data so much as application files and such like. So there's quite a lot of configuration data already out there with JSON in the real world, and you can actually see that this is quite nicely laid out, and that's one of the reasons that I gave it to you. The other reason is it's from pgadmin, and it's got a sensible license that allows me to display it to you. And what you get here is a good example of some real world JSON that's really quite complex, and luckily it's nicely formatted. Okay, now I'm going to go into what some of all this means over the course of the webinar, so don't worry just yet if that's the first time you've seen JSON. So why do people use JSON? Well, JSON stands for JavaScript Object Notation. So obviously if you're using JavaScript, then it's exactly the storage format that you want to use for your applications, because then it's just natively using that data. And as a result, JSON is now a very, very common format. And that means that you see messages being passed in the JSON format, but you also see data being stored in that same format as well. Now, one of the reasons why we would use JSON is really that XML, which was a sort of earlier format for roughly the same thing, is just too verbose, and it makes it very difficult to use. So JSON's a lot easier and sort of much more easily compressed. And of course, other databases use JSON as well. And so you may wish to migrate some of that data to use with Postgres. So there are good reasons to use JSON. Less good reasons to use JSON would be that you can add new fields easily to JSON. Well, that is a complaint that people made, but it really refers to Postgres the way it was back in about 2005, because at that time it was relatively easy to add or remove columns from your database tables. But what we should reflect on is the fact that you can add columns, you can drop columns, and you can change the data type in some respects just simply as metadata only commands, which means they're lightning fast and you can deploy them easily. Now, as a result of that, this idea that we need a format that allows us to be extensible and to add new features to it doesn't apply as often as it might. Okay, so if your JSON looks a lot like a relational table, then my advice would be use a relational table, right? Deploy your data in columns. Now, obviously, there are many applications that don't look like that use JSON, and they're perfectly good and valid applications of JSON. But one of the most important applications we see in the modern world is dynamically tagged data, where we are able to run predictive analytics and assign particular tags to various outcomes. And so if those outcomes occur, we are then able to respond dynamically on web interfaces and such. Now, that kind of dynamic tagging application is a very important use for this type of system. So I do not think that JSON and columns are like exactly equivalent. There are lots of things that you would want to do with JSON that you cannot do with a simply a sort of rigidly relational system. Okay, so that's a clear recognition that Postgres needs JSON in a way. Now, if you think that that's a major admission on my part, yeah, absolutely not, because Postgres is post Postgres, right? It came after Ingres. It's designed to be a post-relational system. So we're not hampered by the thinking that everything has to be relational in Postgres. We've actually got a situation where we can think outside the box. And yes, we need JSON in modern applications. And that's what this webinar is about. So what I'm going to do now is I'm going to take you through JSON at the data level from a database perspective. And what I'd like to do, first of all, is create a table to put some data in. And then I'd like to load some data into that table. So just to keep things simple, I'm going to create a table, and the name of the table is just simply J, okay? And it easily, it's got one column in it, and that column is called JDoc. Now I'm going to use the table called J and the column called JDoc throughout all of the rest of my examples, okay? Now JDoc is a column like any other column, but its data type is JSONB, and that stands for JSON in binary format, okay? So I'm going to use JSONB for everything, okay? I'm not using just simply JSON, and I'm not even going to get into a big discussion of why. So if you want JSON in your database, use JSONB, end of, okay? No further discussion. Now, in order to load data into that collection, let's call it that, we can do an insert into J, select, and then we're using a function called JSONB build object. And this is easy to use because what it allows us to do is put in a number of different fields into the JSON, and those fields are one per line. I've structured it nicely so that you can see what's going on. So we're going to have a field called OID, and that's going to have a value, and then there's a field called OTS, and then it's going to have a times value, and then a field called price, and that's going to have a numeric value. Now the generate series command there means that I'm actually going to insert one integer into the OID field, but I'm going to generate 10,000 rows. I'm actually generating 10,000 separate JSON documents, and the other values are going to be all different because the clock timestamp will vary across rows, and obviously the price will vary randomly because that's the function that I'm using. So that's a fairly easy command to write, and I hope you see you can extend that to generate your own data within your own test databases. So it's very easy to generate sample data. And if you want to then display the data, you can select the data directly from the table. So a very simple select would be select JDoc from J. But what I'm doing here is I'm using a function called JSONB pretty to make the output look nice, in that it's got nicely laid out white space. And I'm also, instead of listing out all 10,000 rows that I just added to my table, I'm using a sampling command, so I'm actually just bringing back a couple of rows, or in fact one row. And then beneath that, you can see that I'm actually showing some of the JSON that I've generated. So you can see each of the rows in the J table is a valid JSON document with 3 fields in. Okay, so OID, OTS, and price. Now, an interesting thing here is that there's a command /pset line style old ASCII, and what that does is it removes the plus sign from the end of the row when you use JSONB pretty. So if you're actually executing these commands while we speak, then make sure to use the /pset command so that your JSON appears actually as pretty as you would like it to appear. Okay, that was if you were using PSQL, but what if you're using another interface, for example, pgadmin? Well, if you type that command into the pgadmin interface, then you'll see that we have select JSONB pretty from J, and rather disturbingly, what you get is a load of lines that just simply have a curved bracket at the beginning. So you're thinking, oh, this is weird. Where did my data go? Why does that look completely different to what I got in PSQL? So there's a couple of ways that you can handle this. What you do is you take the cursor and you hover it over the cell that's got the JSON in. And when you do that, you get this dark pop-up appear, and that shows you the data that's in that cell, and that allows you to actually view the JSON. Or there's another way, you can actually double click on the cell, and what happens is you'll get a multi-line pop-up window that allows you to see the JSON as well, and then you can cut and paste and edit it and that kind of thing. So you know, a couple of different ways to view your data, either in PSQL using the pset and normal queries, or within pgadmin using the same SQL but just a slightly different interface in the query editor. So what do we actually get when we look at JSON? Well, all of the fields are always enclosed in double quotes. So that's the OID field, not a column, it's a field, because all of this data is one column value in a table, okay? So this is a single column value, and we refer to the individual elements within the JSON as fields, and then we call these values. So the OID field has got a value of 521, and the description field, or DESCR field, has got a value of example of some text data. Okay, so the price field has got a value of 5.62. Okay, so these are all normal, what we call top level fields, but they can be different types in normal JSON. So you can have integers, numerics, you can get timestamp or text, and you can also get true and false or Boolean fields. Now, where it gets more complex with JSON is that it's possible to have JSON arrays, and here I've got a field called tags, and the field tags, the value of it is a JSON array, and that JSON array has 3 elements within the array: blue, green, and red. And then we also have a field called ADDR, obviously standing for address, and that is a nested field. So the value of ADDR actually is another JSON document, and that JSON document has got fields called city and state. Okay, and lastly, there's a field called other, which has the value null. And I'll go on to tell you later exactly what that means in JSON. So don't worry about that for now. But the important thing to realize is that some fields are what we call atomic values, and other fields are nested data, and other fields also have array type data. And that's exactly the same to the way that Postgres already worked with nested data types and arrays. Okay, so Postgres is not really troubled by any of this. Okay, it's easy for us to store and manipulate this data. So if you have format errors in your JSON, such as putting a comma in the wrong place, then you will get an error message saying invalid input, expected a JSON value, and then it will tell you the context information. Now, while I was researching this webinar, I actually noticed that the error message that you got back actually had a bug in it itself, and it always, pretty much always told you it was in line 1. So I've submitted a bug report into Postgres, which will hopefully be backpatched to all supported versions, that tells you the correct line on which the error occurred. And I'm shocked really that I never noticed this before actually, but you know, I guess I didn't make as many mistakes in the past as I did preparing this webinar. But no, I mean, it was quite confusing to me to try to understand how JSON works when there was a bug in the error report. But now I fixed it. Now I understand what's going on with some of the JSON, and I hope you do too as well. So what I'm going to do now is talk to you about what types of SQL we can use with JSON, and you know, how to get access to that data. So first of all, I'd like to show you how you can edit the data, or not. Edit is quite the wrong word because it makes it sound like it's a function of pgadmin. How do you submit SQL DML statements that allow you to add and remove fields from your JSON documents? Okay, so if you look at the first one, you'll see that we're doing an update on the table J. We're setting the JDoc column equals JDoc, and then here we're using the append operator. And what we're saying is we're appending what looks like a miniature JSON document, and it absolutely is, okay? And what that does is it will merge the two documents together, and it will overwrite the value in the right-hand side will overwrite the field on the left-hand side if the names match, okay? So in this first case, if you remember what my JSON looked like, there was no field called new field, and so this command will literally insert a new field into the JSON document called new field. If there was a field called new field, then this would simply update the field. So it doesn't matter whether it's there or not, it will do like an insert or update depending on what's required by your data. Now, if you want to add multiple fields at the same time, you can do that using a compound JSON document like this. So it can just expand as big as you need it to be. And that's what makes it easy to parameterize this type of request, because then you can just use one parameter and you can put all the data you need into that one parameter. If you want to remove a field from a JSON document, then you simply use the minus operator. And if you want to remove multiple fields, you can do that again using a single parameter by supplying an array of field names. And alternatively, you've got an operator called hash minus, which allows you to remove an exact path in the situation where you've got a nested hierarchical JSON document. And so this is actually a path. So what it will do is it will look at the address field and then look at the city field within the address field and remove that one. So this will remove the line that says City, New York. So if we want to update values in the JSON doc, we use the same concatenate operator as we did before, but beware that this actually has replace semantics. So if you try to append a new tag value onto an existing array, the new array that you supply will overwrite the existing array. So here I am trying to add the tag yellow to the array, and what I actually do is I accidentally replace it. So instead of blue, green, red, yellow, it just says yellow at the end of it, okay? So you need to be very careful to add things in the right way, and the right way here is to actually use a function called JSONB insert, and what that will do is it will inserts the yellow element value into the tags array, and I've put 999 at position 999, which hopefully is the end of the array. Might not be, but that will then give me an output for tags of blue, green, red, yellow. Okay, so this is an example of a nested array within the JSON document. So we can extract the field values from a document one by one if we want to. So JDoc minus sign greater than, which looks like an arrow, and then quote OID quote from J will retrieve a field called OID if it exists, and the single greater than sign returns JSONB data. Okay, and the second example here, select JDoc field OTS, will retrieve a field of type timestamp, and that will appear in quotes because that's how that data was stored. Now you might think, oh, that's really annoying. I need to use a trim command to remove the double quote from either end of the data, but you don't actually. What you need to use is the minus sign greater than or double arrow operator. And what that does is it automatically strips the double quotes for you when you retrieve it, and it returns to you as text. So I believe that was one of the trick questions at the start of the webinar, was the answer to which was it returns a data type of text. And there is no spoon was actually just a joke from The Matrix, in fact, and other good movies. So that's how you can retrieve individual fields from the JSON document. And obviously you can use those functions either in the select clause or in the where clause. Obviously you have to compare it with something when it's in the where clause, so slightly different usage, but you can use those functions in both situations. So what I'd like to do now is go into query optimization, because this is really where most people go to fairly quickly with their use of JSON. Is, well, you know, it's all very nice storing it, but how do I index it? Obviously, your starting point for any optimization is always to analyze it, analyze a table, and you'll see here in my example data, I've now got 100,000 rows in my table. And then what I can do is I can have a look at certain queries to see what the selectivity of that query is, both according to the optimizer and in terms of the reality. So you saw that I created the test data so that each document in my database had a distinct OID value. So if I supply a single value like 547, we already know that that's going to retrieve one row. And so when I do an explain analyze, you'll see, yes, I do have only one row that matches that where clause in my table. But the optimizer thinks that I have 500 rows with that value. And that's because at the current time, Analyze does not collect statistics on a JSONB data type column. Now, that's something that we will likely add in the future. As you might expect, collecting statistics on a JSON column is pretty difficult. There's going to be an awful lot of statistics there. So we need to work out exactly how we're going to do that. Until we do that, the optimizer will use a value of 0.5% for an equality condition, and for less than or greater than, it uses the heuristic of 66%. So as you might expect, these values you can see are wrong, and they could lead to optimization challenges later on. What I'm going to do now is I'll show you what happens when we add things, add indexes into the mix. So if you want to add an index onto a JSON document, you can, and by doing it just simply like this, create index on JDoc. What that does is it builds a B tree index, but it builds it on the whole value of the JSON. Now, we already said we're interested in selecting pieces of the JSON. So having an index on the whole thing is very, very unuseful. Okay, so this command will work, but you don't want it. Okay, so be careful not to do this. In general, if you're building a B tree on a JSONB column, it's probably a mistake, unless you're doing something like this, where in the second example, I'm building an expression index on the JDoc column. And the expression is I'm extracting just the OID value from the JDoc column. And so that's almost the same thing as building a B tree index on an integer value. Okay, and so we'd expect the this expression index to be roughly the same size as a B tree index would on a normal column. Now when I retrieve things from the situation, you would hope that the situation would improve, but it hasn't, because at the present time the index does not have any statistics on it either. So what we're going to build now on our table is a unique index, and what I'm going to do is formulate this two different ways. One is the first thing is it's a unique index, but it's an expression index. So I'm retrieving the OID value. But not just that, I'm adding a where clause to say JDoc OID is not null. Now, the reason I'm doing that is I deliberately inserted test data into my system. So if I don't add the where clause, that unique index will fail, because it will say, actually, that is in some cases not unique. So what I've done is I've added a load of JSON documents that's somewhat unique, and then I've also added some data that's not unique. Now, by adding in the where clause, it reduces the size of the index, and it allows me to make it a unique index. Now, what's very nice about this is that the expression JDoc arrow OID implies that that expression is not null, and that means if I use this expression in a query, then it will automatically imply is not null, which will allow the partial index to be used, and therefore it will be used for the retrieval of the row. Now, because it's a unique index, now the system now knows that one row will be retrieved when I do this kind of query. And now the explain and the explain analyze match, in that they're both saying one row. So that's a nice situation. We've managed to improve the statistics for JSONB. Now, obviously, indexing each individual field could potentially mean you'd add a very considerable number of indexes, and that may not be what you want. So the easiest thing to do with JSONB is to use something called a GIN index. Now, a GIN index allows you to index individual pieces of a wide column. And so what we do with the GIN index is we automatically index all of the fields and all of their values. And this is very simple to do. It's just a simple command, create index on J using GIN JDoc. And what this does is, if we go back to look at the JSON itself, this will create an index entry for OID, an index entry for OTS, an index entry for price, an index entry for that field, etc., all the way down. So it includes multiple index pointers per row. And because it contains multiple index pointers, it means the table itself, or the index itself, will be much bigger than a normal B tree, but it's got everything you need in it. Okay, so it contains all fields and all values. So when you add a new field, you don't have to add a new index. You don't have to think, oh, I forgot to index that. It's automatically indexed, which is a very useful property. But obviously the index itself can at times become large, and you should sort of, spend a bit of time looking at exactly what is the best way to define that index. And that is why there is another way of using indexing with JSONB, and this is where we introduce a non-default operator class. And so the syntax for that is JDoc space JSONB path ops. Now what this is a different way of taking the data in JDoc and putting it in the index. So this is a kind of what you might call the recipe by which we make our index. The first recipe just takes all of the data and puts it into the index normally. This recipe uses hashing, okay, which means we take the field and the value and we just hash the value and then insert the hashed value into the index. So what that means is you get fewer entries in the index, but each entry might have duplicates, okay? And so what that means is you will get a smaller index, but there might be some effects related to insert or update performance, okay? Might be, and that's up to you to test. Now, because we're using hashing, that means you can only use this type of index with a more restricted range of operators. So if I look at the last one, it worked with all of those operators, whereas this type of index only works with a restricted range of operators. Now, that might sound like it's a really bad thing, but it turns out that actually those operators are probably the ones that you're going to use anyway. So JSONB path ops is a very good starting place for your indexing, okay? So you've got two different ways, two different recipes. The technical word is operator class, but if you just think of it as a recipe, it's just a way of making the index that has different properties that might suit your application. Now in the future, you'll see that we bring out more recipes. There's lots of different ways that we can build that index, and there will be more operator classes for you to use in the future within Postgres. Obviously, you can always extend Postgres yourself, or professional services people can do that for you to allow you to have different types of index. But that's the two options that you have at the present time. Now, that is not everything I'm going to tell you. I want to go into some further detail about different aspects of development. But remember, this is part one of a multi-part webinar series, and I'm going to go into significantly more detail than I have done so far in the next webinar. And depending on where your questions take us, there may be a third webinar after that where we explore even more detail in certain areas. Okay, so let's go into some other development aspects. So if you type in a query like this one, where spoon is not null, then you'll get an error message, okay? That error message is a joke, by the way. You don't actually get that error message. But you do get an error message if you specify a column that doesn't exist. With JSON, if you search for a field that doesn't exist, the query does not return an error. It excuse me, it just doesn't find any data. Okay, so if I say select count star from J, where a field called spoon exists, it says no, couldn't find a field of that name in the data. Okay, so it doesn't throw an error, and this is a subtle point, because some people would say, well, this is brilliant, you know, finally I can look for something without it exploding on me. And other people would say, well, hang on, that could lead me to errors, because if I'm looking for something and maybe I type it wrong. Now, I don't know if you noticed, but at the very beginning, the poll spelt the word spoon incorrectly. And had we actually executed that on a search when we wanted to find the fields called spoon rather than SPPON, then we would have made a mistake, and we'd have returned 0 rows when we should have returned some rows. So obviously that's a very subtle point. Now, arrays in SQL and JSON are different. So if we look at the two formulations here, we've got an example table with a column called ARR, which is a text array, and another column which is a JSONB. And both of these have got arrays in. Now, what you can see on the second query is that the SQL array starts at element 1, whereas the JSON array starts at element 0. Now, I really hope that you don't really write any code that refers to things by their position in the array. Do not rely on JSON being in a particular order. So I don't want to see any code that says retrieve array element 1, because which one are you referring to? Because in JSON, element 1 is the second element, okay? Whereas in an SQL array, it's the first element. Now that's got to be confusing. So just don't do any applications that require relative position. And the other reason is that the way that the JSON is stored does not maintain the position of fields. So if you look at this, I insert the data with a column called device ID first, and then when I select it back out, they're in a different order, okay? And so this is not the same thing as the ordering of columns in a table, because in a normal table, the columns stay in the same order that we created them in, whereas within JSON, that doesn't happen that way at all. The other thing to talk about is how null works in JSON. So there's a value that you can have for a field. So there's a field called other, and it's got the value null. Now, this is a distinct difference from the total absence of a field called other, okay? And what I've done is I've written a query to illustrate the differences. So if I retrieve the column value with a single arrow, and I test whether the answer is null or not from an SQL perspective, then on the third row, I get false, it's not null. Second row, yes, it is null because there is no field. And then on the first row, in SQL terms, it is not null, but in JSON terms, the value is the word null. And that's quite confusing. And it's even more confusing when you use the double arrow, because in that case, we retrieve the value as text, and the text value JSON null comes back to text as an empty string, or in fact as a null value. And so that becomes the SQL value of null. And you can see that the single arrow and the double arrow are different in the way that they retrieve the JSON value of null, but they're the same with respect to a missing field and a field with a value, okay? So I'm sorry if that is particularly confusing. You just have to look at that a couple of times to understand it. Now, because of that, what I'm saying is that it would be a good idea to have the PSQL parameter pset null set so that it actually shows it as a slightly different value. Otherwise, you're going to have SQL null and JSON null in your queries, and you won't be able to tell the difference easily between them. In fact, you'll probably forget which is which. So use \pset in order to visualize the data that you're using. So obviously, what I'm trying to say here is that Postgres, as we know, is strict about data types, and that difference can lead to annoying errors in that you get Postgres will reject your syntax, or it can lead to actually invalid SQL that return the wrong answer. They return an answer that you did not intend. Okay, and that is obviously not very good. But the last thing to say is that using the wrong data type can also lead to poor optimization, because you might end up with a non-indexable query as a result of that. And here is a good example where trying to edit the data with the minus operator and forgetting to add the cast to a text array means that it does the wrong thing. And it looks right, but it does the wrong thing in your application. And that's why one of the most important things I have to say is for you to make sure that you test your applications. Now, was there a question about that? Did I see?
There are quite a few questions, and some of them are really detailed. So I think we're going to have to follow up with questions after the session.
Right. So let me try to. Yeah, I mean, so can DDL return the structure of the JSON? Okay. There is a more complex answer to that question, in that you might want to map your JSON into a table, and there's a whole set of functions for that. I'm not going to cover those today, but this idea of the JSON having structure doesn't really exist. The fields can be in any order, okay? So a JSON document doesn't have the same structure that, say, your table would, okay? The other thing that I'm being asked is, when do I use a single quote versus a double quote? Well, all of the fields inside the JSON are always enclosed with double quotes, but the whole value is enclosed within a single quote. So the value that is the JSON document is enclosed within single quotes. So if I just go back to these examples here. So this is a single JSON document, and if I wanted to quote that to SQL, there'd be one single quote at the beginning and one single quote at the end, and all of the different fields have double quotes within that, okay? Now, there are some situations where you use single quotes to SQL. Here you'll see that you use a single quote, and that is because the formulation of the single arrow operator requires that. So although spoon is a field, if you use a double quote there, the SQL parser will get confused and it won't understand what you're saying there. Okay, so you do need to use single quotes. Now, I can only apologize. I will be looking at ways to try to simplify this, but after a while, you do get used to it when you're programming with it. So that's, you know, it's a good question. Right, so I'll be going into performance implications of changes in the second session. So if you can come back for that, I've got a whole section about update performance and that kind of thing. Right, so somebody's asking me about MongoDB is very popular and schemaless applications in development teams. How would I rate compare Postgres? Well, it depends on what dimensions you're considering to compare. Postgres and Mongo both support JSON. So if your only thing that you need is JSON, then they are in some senses comparable. Okay, there are no disadvantages to using Postgres with JSON. Okay, so we've spent many years adding additional functionality here to make sure that you can easily write the type of applications you write in Mongo can also be written in Postgres. But the key difference that you get with Postgres is you can use all of these other features and data types as well. Okay, Mongo was designed in a very minimalist way, and it didn't include some of the great range of features that you get with Postgres. So if you want to use those other features as well, you definitely can with Postgres. And in terms of the way that the JSON works, it's you know, there's nothing shabby about Postgres. Right, so in the next session, which is advanced, I am going to talk about how you copy data from JSON to a table and back again. I've got that as a data mapper use case that I'm going to explain in a lot of detail. So, is there a limit to the number of nested fields allowed within a column? No, there's no limit within the JSON definition of what you can store. Within Postgres, we can store up to JSON documents up to 1 gigabyte in size. And I'm telling you, if your data's that big, then you've got other problems. Okay. Okay, well, look, so what I'm going to do is press on. I've got about another 5 slides to end, so I'm not going to end exactly on the hour. If some people have to go, thank you very much for your time, but I do have some further slides. What I'm going to do is make sure that we get copies of all of these questions so that I'll be able to go into them in more detail in the forthcoming presentations. All right, so thank you for your questions. I'll just wrap up the remaining topics I have. So I did actually have a few points to make about converting from Mongo. Mongo talks about JSON, but it actually calls the JSON that they store BSON, or so sort of binary JSON, and that's you know, quite comparable in many ways to JSONB data type within Postgres. So if you look at the JSON that you get from MongoDB, then it will typically have a hidden ID column added into every JSON document. And what I'm going to show you in the next webinar is how we can add that automatically using a trigger. So that's all worked out and easily doable. Now, when you're trying to read this, actually this is invalid JSON because you're not allowed to have particular words here without it being in double quotes. So what you can do is you can actually write functions that will remove that data so that you can load that using a before trigger. Okay, that's one way you can actually read data that comes out of Mongo into Postgres. Or another way of doing it is actually to connect directly to the MongoDB database using something called a foreign data wrapper. And what that allows you to do is define a connection between Postgres and Mongo, and then you can just pull the data directly out of Mongo. Now, the nice thing about that is that when you do that, it removes all of this crap about BSON, and it formats it nicely as JSON, and that allows it to be read and usable directly within Postgres. Okay, so that's one really good reason for using this mechanism. So it comes an extension. You can just say create extension and then add it directly into your Postgres server, and then after that you can actually map the JSON data that comes back. You can either read the JSON directly and manipulate it using the JSON functions, or you can actually map it to table columns, and then you can read the JSON as if it was a table. And I'll show some examples of that in the next webinar. Now, interestingly, using this foreign data wrapper, you can execute inserts, updates, and deletes, and those will go back and push changes directly to MongoDB, okay, if you need to have an application that has them working together, okay. And this is obviously all supported by EDB. So my summary of points about JSON development is you definitely have to write tests for this, okay? This idea that you can have sort of dynamically creating fields is great, but that does not mean you don't test your application, okay? If you are doing things right, then you can use JSON for its advantages, but you'll also make sure that you do that with proper automated testing, using a sensible and hopefully pre-existing test framework. But there's a couple of things I've put in green as well. Automate performance testing of your key access paths, so you can be sure that you've got the correct plans when you're accessing your JSON, okay? It's not good enough to just hope that your queries will be properly optimized. You actually need to plan for that. And you also need to plan for what's going to happen to your JSON, because obviously one of the advantages of JSON is the ability to extend the fields within the JSON document, and so you should plan for that in your SQL. You shouldn't assume certain things about the shape of the document. You've got to assume that the documents will change over time, and you mustn't be in a position where your applications will break just because somebody added some new fields or some new structure to the JSON. Those really are the most important challenges. And obviously, because the fact that some of these searches don't throw errors if you can't find a field name, then that actually means that you could get yourself into problems. So what I'm going to do is I'm going to explain all of that in the next webinar. So I know that I've said that about 20 times, but apologies for that. I wanted to give a decent general introduction to JSON before we go into the murky depths of schema design and such like. So conclusions. What we're aiming to achieve with Postgres is a database that supports multiple models. You can use relational data, you can use JSON data, you can also use XML, time series, historical, graph, and GIS, all within the same database system. And this is really the strength that we get from Postgres. Obviously, EDB is sponsoring this, so need to mention that EDB do support production versions of Postgres. So that's pure Postgres is supported by EDB. They also do RDBA, and they have a range of different tools and such likes. But one of the most important things that EDB gives to the Postgres community is that we're at the forefront of maintaining and extending PostgreSQL. And in that regard, I'd like to thank some of my colleagues who helped make the presentation today. Okay, so that is just slightly over an hour. I hope that's been a useful introduction to the basics of Postgres. What I'll do is I'll actually write up some of your questions into a follow-up blog that explains some of the points that you've asked as questions. If you've got any other comments, you can write to me directly, or obviously, you can respond to the webinar invites and such like. So there will be a second part to this, and depending on where the questions take us, there may well be a third or even a fourth part to this series about JSON development. So I do aim to answer all of your questions, so please do ask them in full. But obviously, it's difficult to write specific queries for you. Right, so 27 questions is quite a lot of questions. So thank you for those. And I say I will go through and answer all of them, but I'll try and do a few of those now. Right, so yeah, if a field is removed from the JSON, then there will still be a pointer in the index that points to the row, but obviously the way that indexes work, it will visit the row and then realize that it no longer has that field, and so it will slow things down. So JSON indexes do need to be rebuilt, possibly on a regular basis. Now, what might surprise you is that typically all indexes need to be rebuilt on a regular basis, and that's why Postgres supports reindex concurrently to allow you to do that, because obviously it's very important. Can I explain about the full text search capability on JSON fields? Yeah, in another webinar, and that is not a 2-minute question.
And so, Simon, just a reminder for everyone too, we'll be sending out the recording and the slides from the session afterwards. I'll be collecting all the questions to provide with Simon. Also, there's a survey that will go out once we end this session. So if you have any additional feedback for us on what you'd like to see in the future, there's space to put that there as well. So I think with that, we're just about at time, unless you wanted to.
No, I think I've answered all of the questions that have relatively easy answers.
Right.
That's, some of the questions that have been asked have, the longest one's got like an hour-long answer. The simplest ones are, can be answered in minutes, but a lot of them need further detail. And I will answer all of these questions either in blogs or in later webinars. Okay, so thank you very much for attending today, and thank you very much for all of your questions.
Great. Thank you, everyone. Goodbye.
Goodbye.